So our last lesson in chapter 9 is taking all of those trig ratios that we learned about last time and applying them in our different pictures and situations in order to be able to use a trig ratio to solve for a missing side length or to solve for a missing angle measure in a right triangle. So, we talked in the last lesson about these trig ratios, how they are ratios of size. We found all these patterns. And really the biggest, coolest thing about it is that this now was the first time that we could connect a side length in a right triangle to an angle measure in a right triangle, and we could never do that before. So I'm going to show you how to do that. It will require you to use a calculator. Way back in the day, they just had big tables of all these trig ratios, and that people just had to either carry them around with them or memorize them. In fact, there's a table in your textbook if you have one at home. But you are going to have to use a calculator now, so the calculators store all of that information for you so you don't have to memorize it or carry around a table anymore, which is pretty cool. So you will need a calculator. I highly recommend that you have a handheld calculator like we put on your school supply list that you should be bringing to school every day. If you absolutely don't have one of those handy, then I definitely recommend that you go to Google and use the Google calculator that looks like this rather than the calculator on your Chromebook, because this will have a lot more things going on that you can do, and I'll show you how to use this one. But the one that's just on your Chromebook doesn't have enough, and it kind of messes a few details up. So just make sure that if you are not using the handheld one, that one is definitely easier. If you're going to use an electronic one, that you go to Google and do the Google calculator rather than the one on your Chromebook. So let's get started here and see how we're going to use that. So I have two different triangles here, very similar, but with different information given to us in the problem. So notice here in the triangle on the left, so I am looking at this one right here. Get that one drawn in your notes. Notice that segment AC is 20.1, angle A is 34 degrees, and I am trying to find the measure of segment AB. Also pay attention that I do have a right angle in here, because remember, you cannot use a trig ratio unless you have a right triangle, and I do have a right triangle, so that's great news. So what do I see in this picture? I see I have that an angle of 34 degrees, right? So I'm given an angle of 34 degrees. I'm trying to find AB, which is marked as X in my picture. And I'm given the 20.1. Now it looks like the 20.1 is across from the right angle, so this would be the hypotenuse, right? So if I am thinking in terms of our trig ratios, because I don't have enough information to use a Pythagorean theorem or a triple, and 34 degrees certainly isn't a 30, 60, 90 or a 45, 45, 90. So I have to think in terms of a trig ratio. So I have the hypotenuse, and in relation to this 34 degrees, I notice that the side I'm trying to find is the adjacent side, right? And if you think back to yesterday, SOHCAHTOA, right? SOHCAHTOA was the way that I remembered our trig ratios, right? Sine was opposite over hypotenuse. Cosine was adjacent over hypotenuse. Tangent was opposite over adjacent. So it looks like I have adjacent and the hypotenuse, which means that I have cosine. So I could say the cosine of 34 degrees, right? That's the angle that I'm going from. The cosine of the 34 degree angle equals X over 20.1, because cosine is adjacent over hypotenuse. So I can use that trig ratio to set up an equation, and I can use that to solve. Right now, remember, I'm trying to solve for X, so I have to get X by itself. So in order to do that, I need to get rid of this 20.1. Well, right now it says X divided by 21, so to get rid of it, I could multiply it times 20.1. Now this seems like maybe a step that you don't need to show, but you absolutely do. You have to show the step where it says X equals 20.1 times the cosine of 34 degrees. you have to have that step in your work, because now at this point, you're going to type that into your calculator and you're going to get an answer in round. So you have to prove what you're actually typing into the calculator, so I can see if you have that part correct. And then maybe if you goof up rounding or something like that, then I'll know it was just a math error. But you have to show this step where you have X by itself, everything is moved to the other side, and it's exactly what you're typing into your calculator. So now pull that calculator out. If you have to use the Google calculator, that's okay. So this is what it's going to look like. Now I'm trying to type in 20.1 times the cosine of 34 degrees, right? Now a really big important thing is up here in the top left, over here, I'm clicking it a whole bunch of times because I want you to see where I'm looking. You need to make sure that the DEG is the one that's in black. We want this to be set to degrees. Radians is another unit of measure, kind of like meters versus feet, and we're dealing all in degrees, right? 34 degrees, so we want to make sure our answer is in degrees. So make sure that the degrees, the DEG is in black. That'll be the one that you're using. And then I just type in 20.1, oops, missed my point. 0.1 times, now over here on the left, you should see your trig ratios, right? So times the cosine of 34 and close my parentheses. So that should look exactly like the step of work that we have, right? 20.1 times the cosine of 34 degrees, and I hit equals. So I get 16.6636. So every time that you have a trig ratio, I shouldn't say every time, but almost all the time, your trig ratio is going to come out to a really crazy decimal. It's going to be an irrational number, and you're going to have to round it. So if it doesn't, I mean, it should tell you on every single problem what you are rounding to. So read carefully. In this case, for these, let's round to the nearest hundredth. Hundredth is 2 decimal places. So if I just copy exactly what it was on the screen, it was 16.66365, etc., 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 right? So if I want to round to the nearest hundredth, then I'm going to look at the second decimal place, right? 16.66. Yes, the one after it is not telling me to round up at all. So my final answer would say that X is about 16.66. And that will be my final answer. So that's where we're going to use that trig button, right? You get X by itself, and then you just type exactly how it is with that trig button on your calculator. Pretty awesome, right? First time ever, we can take one side length and one angle measure that's not one of our shortcuts and use it to find missing parts of our triangle. All right, now if I look over here on the right, so this is the triangle over here, very similar, but some different information. So this time AC is still 20.1. But this time I'm given that segment BC is 11.2, and I'm trying to find the measure of angle A. Well, I still have my right angle in there, correct? So 20.1 is across from the right angle, so that would be the hypotenuse still. If I'm looking from this angle A, so from where X is in my picture, the 11.2 is the opposite side, right? The side opposite of the X. Since I have the opposite and the hypotenuse, that's when I want to use sine. So katoa, right? Sine is opposite over hypotenuse. So I would say the sine of angle A equals, actually, I should say, actually, I apologize, the sine of X, right, equals opposite, which is 11.2, over hypotenuse, which was 20.1. Now, many of you would want to reduce that fraction, 11.2 over 20.1, but just don't do it. You don't need to. You're going to use your calculator anyways, and if you try to reduce something in your head and you goof it up, then you're going to get a wrong answer where your calculator will get it right every time, so just leave it alone. The thing is, though, I'm trying to get X by itself. That means that I have to undo that sine operation. How do I undo the sine operation? I need to do the inverse of the sine operation, which we don't really know what that is, but the inverse is always represented by this -1 exponent, right? So I want to do the inverse sine of the fraction 11.2 over 20.1. So this is something very different. We haven't done this before, right? I want to undo the sine function, so I want to do the inverse. And I need to do the inverse of the other side in order to have x by itself, right? Whatever I do to the left, I have to do to the right. So I need to do the inverse sine function of 11.2 divided by 20.1. Now, lucky enough, your calculator can do that for you. So over here on the left, again, make sure we're hitting on the degrees, right? Over on the left is this inverse button. Now notice when I clicked it, I got the sine to the negative first power, cosine to the negative first power, tangent to the negative first power. That's what I want, right? I need the inverse sine, and when you tap it, it comes up as arc sine. That's okay, that's a mathematical term for inverse, so don't worry about it. But again, if I go back to the very beginning, right, I hit the inverse button over here, and I want the inverse sine, and it will show up as arc sine, and that's okay. And then I'm just going to type in my fraction, 11.2 divided by 20.1. So that should look exactly how we had it, right? Inverse sine of 11.2 over 20.1. If you're using your handheld calculator, it stays as the inverse sine. For you, you would have to hit second and then the sine button, and that'll be the inverse sine. And then we just figure out what we get. We get 33.863340, etc., right? So if I write down exactly what I got when I typed it in, that would be 33.863340, etc. And I want to round to the nearest hundredth again. So 33.86, and that next number is not telling me to round up. So x is about 33.86 degrees. Okay. So on the first one, we use the regular trig button, cosine. On the second one, we use the inverse sine button, right? And it showed up as arc sine on this one on the Google calculator, but on your handheld, it would show up exactly how it looks like in my notes here in my work, right? So the question is, how are you going to know when do you use the regular button and when do you use the inverse button? Notice on the first problem over here on the left, I was missing a side length, right? I had an angle measure to type in those parentheses. So when you're missing a side length, that's when you use the regular trig button. So in this case, I was missing a side. I used the regular trig button because I had something to type into those parentheses for my angle measure, right? If I do not have if I'm not finding a missing side, but instead I have a missing angle measure. So notice in the second one here, I was missing the angle measure, and so I don't have anything to type into those parentheses. So that's when I use the inverse trig button. Right? So that's how you're going to tell. If you're trying to find a side length, you can use the regular trig button because you should have a number for the angle measure to type into the parentheses. If you're missing an angle measure, that's when you have to use the inverse trig function because I don't have a number to type in those parentheses. I have to undo the sine function. All right, hopefully that helps you. But now, you know, it's not just here's a triangle, find a missing side. A lot of times we have real-world situations where we can use these. So here's our first one. Oscar is attending an assembly outside where they're saying the Pledge of Allegiance. He is standing 16.8 feet away from the flagpole. So here's 16.8 feet, right? And the flagpole is 8.2 feet tall. So this is 8.2 feet. What is the angle his head is making, or I should say, what is the angle his head is making, I apologize, to look up at the flag? What is the angle his head is making? So we're trying to figure out what is this, you know, I'm assuming, I guess I should have my guy a little bit down farther. Maybe I should just move all of this up. Right here. But you get the idea. So what is this angle measure that he's looking up at the flagpole, right? This is what I'm trying to find. my picture isn't fabulous, but you get the idea. So he is 16.8 feet away from the flagpole, my 8.2 feet flagpole tall. What's that angle to look from the ground up to the flagpole? Well, let's see. If my angle is what I'm trying to find, I have the side across from this angle, so this would be opposite. And I'm hoping that my flagpole is standing straight up and down, which all flagpoles are, or it's unpatriotic, right? And so there's my right angle. So I don't have the hypotenuse, but I do have this opposite side, and I have the adjacent side, right? So I'm going to be using tangent. So the tangent of x equals opposite is 8.2 over adjacent is 16.8. I am trying to find a missing angle measure. So again, this is going to be a time when I would use my inverse trig function, right? Because I have to undo the tangent. I don't have a number to type in the parentheses. So I want the inverse tangent then. So x equals the inverse tangent of 8.2 over 16.8. And again, don't try to reduce that fraction. Let your calculator do the work, okay? So let's type it into our calculator. And I have the inverse tangent of 8.2 over 16.8. I get 26.0167. All right. Et cetera, right? Now, it's probably should tell us what to round to. I apologize that I didn't have that in there. Let's round to the nearest whole degree on this one. Round to the nearest degree. Because we're talking about angle that our head is making, we're probably not going to be able to get really specific, right? And tenths in our picture is a little bit off anyway. So let's just make sure that we are rounding to the nearest degree. So 26.0167 degrees. If I round that to the nearest degree, that would be is about 26 degrees. So the angle his head is making to look up at the flagpole is 26 degrees. So when I have an angle like this, where it's from flat looking up, right? From flat looking up like this one is right here, this is called an angle of elevation. An angle of elevation, again, is always from flat looking up. From flat looking up, angle of elevation. So the angle of elevation in this problem is 26 degrees. All right, so here's our next problem. Ooh, here's a fun one. You could do a rough sketch. Doesn't have to be amazing like this. Spider-Man is standing at the top of a building and needs to get across the street to land on top of the lower building across from him. He's out of web fluid, so he's going to have to jump. The street is 23 feet wide, so this is 23 feet wide, right? And the angle of depression that he is looking is 43 degrees. So he's trying to get to this building over here, right? He's standing on this one, and he's trying to get over to the lower one over there. It says the angle of depression is 43 degrees. Now in the last problem, we had an angle of elevation, right? It was from flat looking up as an angle of elevation. So when I'm talking about from flat looking down, that is an angle of depression. So I would say from this flat horizontal looking down at this building, this angle right here is 43 degrees. So this was an angle of depression. Angle of depression is from flat looking down. So from flat looking up is an angle of elevation. From flat looking down is an angle of depression. All right. So the farthest he can jump is 30 feet. Will he make it, or does he have to climb down and run? So we're trying to figure out how long is it this actual jump that he's going to have to make, right? And if it's more than 30 feet, he's not going to make it. He's going to have to get down and run across because he's out of web fluid. All right. Now, how are you going to figure this out? See if you can't. Pause your video and find a triangle. Well, if I need to have this 43 degrees in my triangle, hopefully you kind of thought of something like, well, what if this went straight up and down? Here's my right angle then, right? If I know it's 23 feet down across the bottom, then it's got to be 23 feet right up here at the top, right? So my 43 degrees is this angle measure right in here. So now let's see. I have X would be my hypotenuse, because it's across from the right angle, and the 23 feet is the side right next to my 43 degrees, so this would be the adjacent side. So I have adjacent and hypotenuse, so that would be cosine. So the cosine of 43 degrees equals adjacent 23 over hypotenuse x. Ooh, tricky. Now I need to get x by itself. Now this was stumped some people for a little while because they're trying to remember, how do I get x by itself if it's on the bottom of the fraction? Some people say divide by 23. Okay, but I would still have x on the bottom of the fraction, right? So what I need to do if I want to get something off the bottom of the fraction is I multiply by that number, right? This clears the fraction. So I have to start by clearing the x off the bottom of the fraction. So I multiply both sides by x. So I have x times the cosine of 43 degrees equals 23. Now the cosine of 43 degrees is just a number. It's a complicated placeholder, but it's just a number. So to get x by itself, I need to divide both sides by the cosine of 43 degrees. So they cancel over here. So I have x equals 23 divided by the cosine of 43 degrees. And yes, you need to show every step of that work. That's all crucial. And I have to have every step, but now I have x by itself. So I have x by itself, so I am going to type that into my calculator. So I have 23 divided by the cosine of 43 degrees, right? So this was the regular trig button because I have an angle measure to type into those parentheses. 23 divided by the cosine of 43 degrees. I get 31.4485. So let's see, x equals 31.44 something or other, right? 4485, etc. All right, so that would be about 31 feet. The farthest he can jump is 30 feet. Oh no, he won't make it. So he has to get down and he has to run and hopefully he catches the bad guy, right? But that's the idea here. So, you know, life and death situations here, guys, right? I mean, Spider-Man must use it every day. But just some some real world application to our trig ratios. And just the other thing that just remember, angle of elevation from flat looking up, angle of depression is from flat looking down, and those come into play a lot when we're using our trig ratios.